Next thing we need to find is our angle. So again, we are given the opposite and the adjacent. We're not given the hypotenuse, so we're going to use tan. We're going to use the information that's given to us, not the information we calculate. The information that given to us is the angle is equal to the inverse tan of 91.0 newtons west, the opposite, over the adjacent, 105 newtons north, which gives us our final answer of 40.0 degrees west of north. So our F net is equal to 139 newtons at 40.9 degrees west of north. And there's your final answer. So now it wants us to determine the acceleration of the object. So we have a couple options. We can go through and we can do all of our directional justification again, to redraw our diagrams, but we already know the direction we're headed. The force and the acceleration we know are going to go in the same direction. So using our formula, acceleration is F net over mass. Our net force is 139 newtons. Our mass is 13.8 kilograms, which is given in the question. And that equals, when you plug it in, 10.1 meters per second squared. When we're determining acceleration, it's a vector, so we need a direction as well. We already found our direction. It's moving in the same direction as our force. So we can say 10.1 meters per second squared at 40.9 degrees west of north. In the next example, we talk about relative motion. So what relative motion is, it's the motion measured with respect to an observer. This goes back to our first unit when we talked about relativity. So some objects move within a medium that is itself moving. Alright, so this is like when you're swimming through a stream and the stream has a current. Or like in this example, when an airplane flies with an air velocity of 810 kilometers per hour west, the wind has a velocity of 55 kilometers per hour. Determine the ground velocity, so the velocity relative to the person standing on the ground for each situation. So if the object is moving with the wind or current, it appears to be moving faster. The wind is blowing west in this example. So we have our air velocity, that's how fast the airplane is moving, is equal to 810 kilometers per hour. It is heading west. So in our example, actually for this whole page, I'm going to make west positive, east negative. So when we're finding 810 kilometers, we also are moving with the wind in this case, because the wind is blowing west. So we have the velocity of the wind is added on to the end of our velocity of the air. So when we determine our ground velocity, we go from the tail of the first one all the way to the tip of the last one. This here is going to tell us our ground velocity. So we have 810 kilometers per hour plus 55 kilometers per hour, the velocity from the air or the airplane, and we have the velocity from the wind. That all together gives us a velocity of 865 kilometers per hour to the west. This time, the object is moving against the wind. So again, we're always going to have our air velocity heading to the west at 810 kilometers per hour. This time, however, we are moving against the wind. The wind is blowing east. So the velocity of the wind is going the other direction. When we draw a resultant vector, we draw from the tail of the first to the tip of the second, or the last. Let's get a better pen. I don't know how much the better that one is. But that gives us our ground velocity. Like I said before, I'm always going to make, in this example, west positive, east negative. So our ground velocity is equal to 810 kilometers per hour to the west, which is positive, plus negative 55.0 kilometers per hour from the wind heading in the opposite direction. That's going to give us a speed of 755 kilometers per hour to the west. This is why when you take airplanes, so for example, if you're flying from Edmonton to Toronto, it's usually a lot faster flying from Edmonton to Toronto than from Toronto back to Edmonton. It's the way the air currents generally work in Canada. All right? So there is one last example we can do now with what we have been learning this unit. Now the wind is moving at a perpendicular. So the air velocity, or the velocity of the plane, is still headed west with a velocity of 810 kilometers per hour. All right, but the wind is blowing south. It's blowing perpendicular. So it's blowing down. Our resultant vector is from the tail of the first to the tip of the last. So the ground velocity is equal to, I'm going to, for this one, use Pythagorean's theorem again to find this angle. So we have a squared, or 810 kilometers per hour squared, plus 55 kilometers per hour squared, and we want to take the square root of the whole answer. That gives us a speed of 812 kilometers per hour. All right, that's our speed, but we're wanting to find velocity. To find velocity, we also have to have direction. So, to find our direction, we will use what's given to us again, not what we're calculating. So in this example, once again, we're using tangent. So the angle is equal to the inverse tan of the opposite 55.0 kilometers per hour south divided by the adjacent 810 kilometers per hour west. So our resulting angle is 3.9 degrees south of west.